Hello, and welcome back to another video in the game development series. In this video, I'll be showing you how to prepare a scene so that you can navigate using the arrow keys. We'll be adding keyboard controls to move left and right, forward and back, as well as being able to turn left and right. Later on, we'll also be adding mouse controls, so you can use like mouse look commands to direct the way that your head is pointing, and then use the arrow keys to move forward, back, left and right, and so on. But before we can do that, we have to sort of clean up some of our current code so that we can display a scene that we can navigate around in. Again, if you find these videos helpful, then please support my website by going to www.maticnose.com and clicking on the PayPal icon. You can also help support my site by clicking on any of the Google ads that show up on my page. Okay, so let's take a look at what we had before. I did get an email message from a member that was telling me I have some extra function calls in the code that are not required. So I went through and I took a look and I removed them, and everything still works fine, so thank you for that comment. I just want to pass that information on to you guys. What we did here, well, what I've changed is we no longer need to include this winbase.h for create new text. As a matter of fact, the definition for create new text is within windows.h, so we can just remove that line of code. And additionally, if we go into the main.cpp, originally I had this co-initialize at the top here and co-uninitialize at the bottom. Well, it turns out we don't actually need these two function calls, so we can remove them. So we can do that, and we'll do that as well. And we'll see that when we program, everything still runs exactly as it did before. So we see our rotating triangles there. Another thing I wanted to note is I noticed in the last VMK, when I zipped it up, it was pretty big in size. Now I'm guessing that the reason for this is because of the window that we create and all the objects moving around in it that you're viewing in OpenGL. It actually doesn't compress very well when I create these videos. So I'm going to try to keep the display output from OpenGL at a minimum so that I can try to reduce the size of the video files that I'm creating here. Okay, so last time what we did is we created a renderer for a triangle. And what we're doing is we take a triangle and we rotate it about the z-axis so we can turn it, and then we render it using some 3 colors here. Now, I think I might have mentioned before that it would be more helpful if the color code of the triangle was actually stored inside of our triangle class rather than hard coding it here. So what we're going to do now is we're going to actually go ahead and add the color into the triangle class. This will give us a little bit more flexibility while rendering. So to do that, let's go into the triangle class. Let's see where it is here. Triangle. And go into the .h. At the bottom here, we see that we have 3 members for the 3 vertices, as well as the angle that we rotate the triangle about. Well, now we're going to add the color OpenGL specification so that we can select what color we want this triangle to be. Now, since I'm going to be using color OpenGL within the triangle class, I'm going to move our definition for color OpenGL into the triangle.h. So I'm just going to take this here from, which is currently in game OpenGL.h. We're not going to need it here anymore. And I'm just going to put it into here. Now the other thing I'm going to change to this color OpenGL structure is you'll notice we have a set function here which takes a floating point number and sets it to our member variable values red, green, and blue. Well, what I want to do is go, you'll notice in the game OpenGL I created a function called convert color, which takes a color as an integer and converts it into a floating point number. And we used it mainly to specify the color to be arranged between 0 and 1 in OpenGL. Well, we're no longer going to need this in the OpenGL class. I'm going to delete it from here, which also means in the .h file we can go and delete it. And instead, I'm going to go and put it into the color OpenGL class here as a set call. So instead, you notice now we can go set and specify 3 integer values for red, green, and blue. And what it does is it takes that integer value and converts it into a floating point number between 0 and 1. And it does it exactly the same way that that convert color function call did it before for us. Now, we need to go and change our constructor. Since we now have a color member, we need to be able to pass a color into our constructor. So I'm just going to go take this constructor and change it slightly by adding the color OpenGL color here. And then if we go into the triangle.h file, or the triangle.cpp file, for the constructor, we can then add that color item here as well, and then on the bottom here, color equals color. So what we're doing here is we're taking the color that's being passed into us and just setting it to our member variable color. Let's save all of that and see if we can build it. I'm sure we're going to get a couple error messages because we did change quite a few things. Okay. Now, since we removed this function convert color, we can now just pass in our 3 values rather than having to convert them first. And by doing this, these 3 integers are going to get called into the set, which takes and converts the integers to floating point numbers for us. So let's try building that. And we still have another error here. No overloaded function that takes 4 parameters. Right. Okay, so before when we were initializing our scene, we had the 3 vertices and the angle here, which was 0. But now, since we added that the next parameter for color, we also now need to define a color for all the triangles we create. And we can do that just by creating an instance of a color OpenGL structure. I'll call it color here. And I set it to sort of a greenish color here. And then we can take that color and we pass it into our constructor like this. So we'll have a green triangle, and then the smaller one here. Let's go and change the color of the smaller one. And let's make it kind of red. Like this. Okay, let's see if it likes that. Okay, let's give that a run. Make sure it looks okay. Alright. Okay, we still don't have, you'll notice that the colors of the triangles were not correct there. And that's because when we go and render, we still haven't set up to use the colors that are now stored within the triangle class. So to do that, if we go into the render function, you notice we're still using those 3 distinct colors that we specified before. So now what we can do is we can clean up this code a bit. Let's delete these 3 colors here, and instead at the very beginning call the triangle color, set the color of the triangle to be whatever was stored in the triangle class to the red, green, and blue values, and then render the 3 vertices like this. So now we should see a green and a red triangle on the screen. And we do. There's a green one and there's a little red one. Okay, so that's how we modify the triangle class. Okay, now what I'm going to do is I'm going to create a scene that allows you to move around in it using the arrow keys. In the next tutorial, I'll add the code to actually move the camera as well as create the camera class. But in this tutorial, what I'm going to do is just create a very simple scene that will allow you to move around inside. So let's go into the scene here, the scene.cpp file, and actually we need to go into the scene.h, and you'll notice that we have our current objects contain just 2 triangles. I'm going to change this so that I have one triangle which is going to be green. I'm going to use that to represent the ground. It's going to be a really big triangle, and then I'm going to use 6 smaller triangles which I'll position in a certain way so that I kind of create like a corridor. And then using the arrow keys, you'll be able to move down this corridor and turn around and sort of walk around in the scene so you can get a feel for how things are set up in the 3D world. So let's change this here. So I'm going to delete those 2. And so I create one triangle for the ground. I just call it P ground. And then I have 6 triangles here. Just P, T1, triangle 1, triangle 2, triangle 3, and so on. Now doing this means that we need to go into our constructor as well as our destructor and set up everything correctly here. So now we can delete these 2 and replace them with this part here for the ground. We set it to null as well as the 3 triangles to null. And in our destructor we call clear all, which is at the bottom here, and we need to replace these 2 with the delete for the ground and the 6 triangles. Okay, and then in initialize we need to now initialize all of those triangles. So to do that, I'm just going to replace our existing code here with the code for the triangles, the new triangles. So again, I just create 3 temporary variables for the vertices and a temporary variable for the color. And you notice that the first set of vertices I set to be -50, -50, and then 0, 0, 50, and then 50, 0, -50. So this is a really big triangle. That's going to be our ground. You notice that I positioned it so that the y-coordinate is 0, which means it's flat. It's just laying sort of horizontally on the screen. I set the color to be that green color, and I define it to be here for the ground using the 3 vertices, no rotation, and the color to be green. The next triangle here, I give it a new color, I specify some new coordinates, and then I define it, and I just repeat this for all the other triangles. Here's the coordinates, create it, and so on. So I'll just scroll through here so you can take a look to see what the coordinate values are and what color values I've been using. I just chose these color numbers arbitrarily, just so that we can tell the difference between the triangles. You can set them all to be the same color, that's fine as well. Okay, let's do this. Oh, it didn't like something. Undeclared identifier. Alright. In the scene here, when we call update to update the scene, before what we did is we called the update for each of the triangles to rotate them, and then we called the render for each of these. Well, we're not going to be rotating these triangles ourselves, so I'm going to just delete this. We don't need that anymore. And we got rid of these 2 triangles here, but we replaced them with our new ones, so we now need to insert the rendering for the ground and then render each of the triangles, like so. Okay, let's see if this builds. Okay, and then click go. So what we see here is our triangles, and you notice that our big ground here is not displayed. Well, it actually is, but we just don't see it. Now, what's happening is all the position of all of our items happens to be at exactly 0, which is where our eye is. So what we need to do is shift our eye up a little bit in the scene so that we can see the ground, because right now we're sort of looking directly parallel with the ground. We can't see the ground because of that. And to do that, we would then go into the render pre here. You'll notice what we've done is we've set up sort of a structure here where we're going to handle the camera controls, and this is what we're going to be modifying in the next tutorial. What is currently happening is we take the camera position and we move it back 4 units. So instead of doing this, I'm going to just change this, move it back 1 unit, and then move it up 1 unit. Now you'll notice that I'm saying up, but I'm actually typing in down here a negative value. This will make more sense once we implement the camera class, so just trust me on this for now. I'll explain it in detail in the next tutorial. So let's give this a run. Okay, so now we see here's our triangles, here's the green ground, and we sort of see the scene. Now when we use the arrow keys, nothing happens in the scene. It's because we haven't handled that control yet. That's coming in the next tutorial, as I said. And in the next tutorial, we're going to be adding a camera class, which will then allow us to get rid of this and have all of the control done through the camera class.